So let's take a look. We were doing the substitution yesterday, which is basically a technique we can use when we have something that we couldn't otherwise integrate. So like those products and quotients, we could use that. We can also do it with a definite integral. And there's two different ways that we can go through and work with the definite integral. So one option would be to do the problems like we did yesterday. So you plug in your u, you solve the problem, you replace the u back in terms of x, and then you evaluate the integral with the numbers given. So the top number minus the bottom number. The second option is to find new limits that match our u values. So for instance, if we were going to integrate from 3 to 7 of x times x squared plus 1, what would your u be? I'm going to make it really easy. I'm going to make that 2x. So our u is, and what's du? 2x dx. So one way would be to go ahead and rewrite this and say, okay, that inside is u, the 2x dx is the du, and go ahead and change the 3 and the 7. So 3 is an x value. So if you plug it in for this x, 3 squared plus 1 is 10. And then change your 7. So if you plug in a 7, 7 squared plus 1, and then you don't ever have to go back to your x's. Then we just integrate, so it'd be 1/2 u squared from 10 to 50, and we plug in those numbers and work it out. If you don't, if you keep this as the 3 and the 7, then once you get to this point, you have to replace your u with the x squared plus 1 before you go ahead and evaluate. So both options work. It does not matter to me at all which one you do. I tend to change my limits at the beginning just because I think it's easy to forget if you didn't change them and not plug your x back in, and people tend to make more mistakes going the other way. But it is completely up to you when you work through them. So let's take this problem. The integral from 3 to 5 of x dx over 30 minus x squared squared. Alright. This can be written different ways. If you don't like how this is written, you can put the dx on the end. If you don't like the fraction, you could always write that as a -2 power. So whatever you're most comfortable with. But we definitely can't multiply this out to start, so we have to do a substitution. So what would our u be? Then what's du? And we don't need the -2, do we? So we could divide that over, so it'd be -1/2 du equals the x dx. Right, so the x dx is my -1/2 du. The 30 minus x squared is u to the -2. Do you want to go ahead and change these limits? Okay. So, in place of my 3 was an x value. We need to know what u is. So 30 minus 3 squared. Okay. And then let's change our 5. So 5 is an x, we need the u. So 30 minus 5 squared. Alright. So now we are going to work this, and we don't ever have to go back to x's because we put everything in terms of u. So if you add 1 for the power, that's -1. So we need a -1 front, so that's a +1/2 u to the -1. And pull that 1/2 out. So 5 to the -1 means 1/5 minus 21 to the -1, so 1/21. You guys should double check. Come on. This is kind of similar. One of your homework questions last night had like a secant squared and a tangent cubed, and so I had a couple questions like, which one should I make my u? Try to go with the one with the highest exponent. So what would my u be here? Sine, let's just do the sine 2t. So du, derivative of sine is cosine. Angle stays the same, times derivative of the inside, derivative of 2t is 2, and I'll get a dt. I don't need the 2, so that means 1/2 du is cosine 2t dt. So we went to set up this integral. Let's go ahead and change our limits. So if you plug in a 0, 2 times 0 is 0, sine of 0 is 0. We plug in a pi over 4. 2 times pi over 4 is pi over 2. That's like 90. What's the sine of 90? 1. Okay, sine of 2t becomes my u. That was cubed. The cosine 2t dt, that is 1/2 du. And I'm just going to put the 1/2 there in front. So antiderivative, we have the 1/2. Antiderivative of u cubed is 1/4 u to the 4th. So 1/2 times 1/4 is 1/8. 1/4 minus 0 to the 4th. I get 1. You guys need to try one, don't you? I might do the next one and then have you try one though. Is there any way to do this without substitution? No, because we have x's multiplied together. So what should my u be? Du would be yes. Okay. Well, that takes care of some of it. I've got my x plus 5. I have the dx. But the problem is we still have an x here. What am I going to do with that? We did one yesterday. Solve for the x here. So that means u minus 5 is equal to x. Alright, so if I change my limits, if I put in a -4, -4 is the current x value. So if you put that in for x, -4 plus 5 is 1. If I put in a 4, 4 plus 5 is 9. X gets replaced with what? And I have a square root of x plus 5, so that would be square root of u. Could I go ahead and just write it as u to the 1/2? And then the dx is my du. Okay, it's still a product, so I can't do the antiderivative yet, but we could distribute now. So u times u to the 1/2, u to the 3/2, minus 5u to the 1/2. antiderivative of u to the 3 halves? What would that be? So if I add 1, that's a 3 halves. So it gets a 2/3 in front times 5 would be 10/3. Alright, figure that out for me. Mhm, 52 over 15. Alright. You guys try the next one. Oh, this one I didn't even put limits on, so I like yesterday's problem. Du, what's the derivative of cosine? We don't need the negative, so negative du be the sine t dt. So we have the integral of e to the u, we get a negative and a du. What's the antiderivative of e to the u? What else does this one need? Plus c. I put one on there without limits just to make sure you remember you have to put the plus c, and since I don't have anything to plug in, I have to go ahead and replace my u. Let's look at this one. So what should my u be? Okay, since it's a dx, that tells me x is the variable, a is just a constant. So du would be we need the x and the dx, we don't need the negative 2. So if you divide that over, negative 1/2 du equals x dx. Okay. So if I want to get rid of my 0, that's the x value. So a squared minus 0 squared is a squared. If I put in 9, a squared minus 9 squared everybody with me here? So then we have a negative square root of u, or u to the 1/2 du. So if you add 1 to your power, that's 3 halves, so it gets a 2/3 in front times negative 1/2. Negative 1/3. Negative 1/3 a squared minus 81 to the 3 halves minus a squared to the 3 halves. Can we do a lot to simplify here? No, really the only thing you could do, I mean, you could write it with radicals and things, that's not overly necessary. But a squared to the 3 halves, a power to a power, you multiply, so that's just going to give you an a cubed. But that's really all we can do. So that's our final answer. So now you guys have time to finish that homework from yesterday. Remember we did 3 through 39. I assigned that part yesterday, so then we have the rest of the problem, so it's all due tomorrow.